There is a wall in Cusco, Peru that should not exist. Not according to modern engineering standards, not according to what we know about Inca capabilities, and certainly not according to the laws of physics as we understand them. Yet there it stands on Hatenrumiak Street in the heart of the ancient Inca capital, constructed from stones with a level of precision that you cannot slide a piece of paper between, stones that weigh up to 120 tons, carved into impossible polygonal shapes with dozens of angles, stacked without mortar, and still standing perfectly after more than 500 years of earthquakes that have leveled every Spanish colonial building around them. In 2024, a team of engineers from Japan's Nagoya University, working with Peruvian researchers and using high-resolution three-dimensional laser scanning, friction analysis, and seismic modeling, claimed they finally understand how these walls were built. Their findings were published to significant fanfare, presented as the solution to one of archaeology's most enduring mysteries. But here's what the headlines did not tell you. Their explanation creates more problems than it solves. And the deeper you look into what they actually discovered, the more impossible these walls become. The walls we are talking about are not just in one location. They are found throughout Cusco in the Sacred Valley, at Sacsayhuaman, Ollantaytambo, Pisac, and dozens of other sites. But the most famous and most studied are the walls in Cusco itself, particularly the ones on Hatenrumiak Street, where the legendary 12-angled stone sits embedded in a wall that was once part of the palace of Inca Roca. This single stone has become the symbol of Inca masonry perfection. It is about 3 feet tall, roughly rectangular in overall shape, but its surface is divided into 12 perfectly flat planes, each meeting adjacent planes at precise angles. All 12 angles fit perfectly against the surrounding stones, themselves multi-angled polygonal blocks, creating a continuous wall surface so precise that the joints are barely visible. No mortar, no gaps, no cracks. Just stone pressed against stone with tolerances measured in fractions of millimeters. The official history attributes these walls to the Inca Empire, specifically to the reign of Pachacuti in the 15th century around 1440 to 1470 CE. The Inca, according to this narrative, developed sophisticated stoneworking techniques using bronze chisels and stone hammers, combined with incredible patience and massive labor forces. They carved these polygonal blocks to fit together like three-dimensional jigsaw puzzles, creating walls that have withstood centuries of seismic activity in one of the most earthquake-prone regions on Earth. That is the story in every tour guide book, every museum placard, every documentary. But talk to a structural engineer, show them these walls, tell them the Inca had only bronze chisels and stone hammers, and watch their face. Because what they are looking at should not be possible with those tools. Not at this scale, not with this precision, not without technologies that would not be invented for another 400 years. The 2024 research team thought they had the answer. Using high-resolution three-dimensional laser scanning, they mapped the surfaces of hundreds of stones in the Cusco walls, measuring their angles, their surface roughness, their contact points with adjacent stones. They analyzed the friction coefficients between different types of stone. They built scale models and subjected them to simulated earthquake forces. And they concluded that the secret was in the shape of the joints themselves. Specifically, they argued that the polygonal, multi-angled design, with its protruding and receding surfaces, creates a mechanical interlocking system that distributes seismic forces in multiple directions simultaneously, preventing any single stone from being displaced. This sounds impressive until you realize what they are actually saying. The Inca discovered and applied advanced principles of seismic engineering that modern architects would not formalize until the 20th century. They are saying that Inca stonemasons working without written mathematics, without computer modeling, without the ability to test their theories through structural analysis software, somehow figured out exactly how to shape stones in 3 dimensions to optimize earthquake resistance through multi-directional force distribution. But the real problem with the 2024 findings is not what they claim to explain. It is what they completely fail to address. Understanding why the polygonal shapes work for earthquake resistance does not tell us how the Inca created them in the first place. The research shows us the engineering principles that make the walls stable. It does not show us how one carves a 120-ton block of andesite, one of the hardest stones on Earth, into a polygon with 12 or 15 or in some cases more than 30 precisely angled surfaces. All of those surfaces must fit perfectly against the equally complex surfaces of adjacent stones. Let me give you some context on what we are talking about. Andesite is a volcanic rock with a Mohs hardness of 6 to 7, which puts it roughly on par with hardened steel. The bronze tools the Inca had access to have a Mohs hardness of around 3 to 4. In practical terms, you cannot effectively carve andesite with bronze. It is like trying to cut through a steel beam with a copper wire. The bronze would deform and wear away long before making any meaningful impact on the stone. Modern stonemasons working with andesite use diamond-tip saws, tungsten carbide chisels, and pneumatic hammers. Even with these tools, carving a complex polygonal shape into a multi-ton andesite block would take weeks of careful work. Yet the Cusco walls contain thousands of such blocks, many far more complex than anything a modern mason would attempt, all fitted together with precision that exceeds contemporary construction standards. The conventional explanation is that the Inca used harder stone tools to work the andesite, specifically river cobbles of an even harder metamorphic rock in a technique called pecking, where you pound the surface repeatedly to gradually abrade it away. This is demonstrably true for some Inca stonework. Archaeologists have found hammerstones at quarry sites. Experimental archaeologists have successfully used this technique to shape stone. But here is the problem. Pecking creates a rough, slightly irregular surface. It is an abrasion technique, not a precision cutting technique. The surfaces on the Cusco walls are not rough or irregular. They are flat to within millimeters across spans of several feet. When you run your hand across the joints, you cannot feel where one stone ends and another begins. The surfaces are so precisely matched that in many cases the joint is only visible because the two stones are slightly different colors or have different crystal structures that catch light differently. In 2015, a team of experimental archaeologists attempted to replicate a single Inca polygonal stone using only bronze tools and the pecking technique. Working full-time with a team of 5 experienced stonemasons, it took them 6 months to complete one stone, roughly 3 feet on each side with 8 angled faces, one relatively simple stone compared with those in Cusco. The walls in Cusco contain tens of thousands of stones, many far more complex than the experimental replica. Even if we assume the Inca had hundreds or thousands of stonemasons working simultaneously, the timeline does not make sense. Pachacuti's reign lasted about 30 years. The amount of stonework attributed to this period, not just in Cusco but throughout the empire, would require a pace of production that seems impossible given the experimental evidence for how long it takes to create even a single stone. But it gets strange. The 2024 research team, while focused on earthquake resistance, inadvertently documented something else in their detailed 3D scans, evidence that different stones in the same walls show different levels of surface precision. Some stones, generally the largest and most complex ones, have surface flatness and angle accuracy that exceeds the capabilities of the pecking technique by an order of magnitude. These stones show tolerances of less than half a millimeter over distances of a meter or more. That is the kind of precision you would expect from machine tools, not from Stone Age technology. Other stones in the same walls show slightly less precision, still impressive and still far beyond what you would expect from Bronze Age tools, but measurably different. Interspersed throughout, there is a third category of stones that are clearly cruder, with visible tool marks, less precise joints, and overall lower quality. The research team noted these variations but did not explore their implications, because those implications are deeply problematic for the conventional timeline. What you are looking at is evidence of at least 3 different construction phases or 3 different levels of capability. The most sophisticated stones appear to be the oldest, forming the foundations and the most structurally important positions. The intermediate quality stones seem to fill in around them. The crudest stones appear to be repairs or later additions. This is exactly backwards from what you would expect if the Inca were developing and refining a technique over time. Instead, it looks like progressive degradation, with later builders trying to match or repair work they did not fully understand, using techniques that produced inferior results. This pattern is not unique to Cusco. You see it at Sacsayhuaman, where the massive lower courses featuring stones weighing up to 200 tons show incredible precision, while upper courses that clearly came later show dramatically reduced quality. You see it at Ollantaytambo, where the famous 6 monoliths at the Temple of the Sun, each weighing over 50 tons and fitted together with millimeter precision, sit atop cruder stonework. The best, most precise, most sophisticated stonework forms the foundations, while later additions are progressively simpler. Spanish chroniclers who arrived in Peru in the 1530s documented something interesting about these walls. When they asked the Inca who built them, the Inca said they did not know. They attributed the greatest structures to a previous civilization, sometimes called the First People, or connected to the mythical figure Viracocha. The Inca claimed to have inherited these sites, reused them, built upon them, but not created them originally. Now, Spanish chroniclers were not always reliable, and they often misunderstood or deliberately misrepresented Inca beliefs. But multiple independent chroniclers report similar stories. Pedro Tietza de Leon, writing in the 1550s, described walls that the Inca themselves claimed predated their empire by centuries. He noted that the Inca spoke of earlier builders with knowledge and capabilities they themselves did not possess. Garcilaso de la Vega, himself of Inca royal descent, writing in the early 1600s, made similar claims, saying that the most impressive stonework was ancient even to the Inca, who did not know how it was made. Modern archaeology has generally dismissed these accounts as myth or Spanish misunderstanding. The reasoning is straightforward. Radiocarbon dating of organic material in the mortar and fill of these walls consistently gives dates in the 15th century, aligning with Pachacuti's reign. Therefore, the walls must have been built then, the Inca must have built them, and any stories to the contrary are simply legend. But radiocarbon dating only tells you when organic material died, not when stone was carved. If the Inca were rebuilding, repairing, or repurposing existing stonework, adding new fill, creating new mortar, or building upper courses atop older foundations, the radiocarbon dates would reflect that Inca activity, not the original construction date. The 2024 research team found evidence supporting this scenario. In their detailed scanning, they documented that many of the most precisely fitted stones show no evidence of mortar or fill material between them. They are simply stone on stone. The mortar and organic fill appears primarily around the cruder, less precisely fitted stones that appear to be later additions or repairs. This suggests a scenario where the Inca inherited sites with existing megalithic stonework of extraordinary precision, built additional structures using those walls as foundations, filled gaps with new stones of lesser quality, and used mortar to secure their additions. The radiocarbon dates would capture the Inca construction phase while missing the potentially much older initial construction entirely. Let's talk about the famous 12-angled stone for a moment because it perfectly encapsulates the mystery. This stone weighs approximately 6 tons. It has 12 planes, meaning 12 flat surfaces, each meeting adjacent surfaces at precise angles. For this stone to fit perfectly in its position, each of those 12 planes had to be carved to match the corresponding surface on adjacent stones. Stones that themselves have multiple angled planes. The key challenge here is precision. Think about what that means practically. You cannot carve this stone in isolation. Every surface you create has to correspond exactly to surfaces on stones that are either already in place or that you are planning to place adjacent to it. You are essentially creating a three-dimensional puzzle where each piece must be custom fitted to its neighbors. The 12 angled stone interfaces with at least 6 adjacent stones, each of which also has multiple angles. The total number of matched surfaces involved in fitting this single stone into its position is probably close to 30 or 40. Now, how do you do this with Bronze Age technology? Even if you could somehow achieve the surface precision through pecking, which is questionable, how would you measure and plan these angles? How would you ensure that the stone you are carving will fit perfectly into a space surrounded by already placed stones with complex surfaces? Modern stonemasons doing this kind of work use precision measuring tools, laser levels, computer-aided design, and the ability to make minute adjustments through grinding and polishing. The standard explanation is that the Inca used a trial-and-error method, repeatedly placing the stone, marking where it did not fit, removing it to carve more away, and repeating until it fit perfectly. But anyone who has actually worked with stone will tell you this method has severe limitations. Every time you move a multi-ton stone, you risk damaging it or the surrounding stones. The physical effort of repeatedly lifting and placing a 6-ton stone would be enormous. And with each iteration, you are removing material based on approximation. You are essentially guessing how much to remove and from where. This trial and error method might work for rough fitting, but it cannot explain the precision we see at Cusco. The joints are too perfect. The tolerances are too tight. There are too many complex surfaces that all had to come together simultaneously. For the 12 angled stone to fit, all 12 surfaces had to be correct at the same time. If even one surface was off by more than 1 millimeter, the stone would not seat properly, and you would have to start over. In 2019, a computer scientist in California created a 3D model of a section of the Hatun Rumiak wall, including the 12 angled stone. He then wrote an algorithm to try to determine the optimal sequence for placing the stones and the measurements each stone would require to fit perfectly. Even with computer assistance, assuming perfect measuring tools and the ability to carve to exact specifications, he found that the complexity of the fitting problem exceeded what could be reliably solved without modern computational tools. His conclusion was that either the Inca had measurement and planning methods far more sophisticated than we credit them with, or the stones were fitted using a method we do not understand at all, possibly involving some form of stone softening or molding that would allow for adjustment after initial placement. This second hypothesis has been proposed by various researchers over the years and is universally rejected by mainstream archaeology, but it persists because it is one of the few explanations that would account for the precision. The stone softening theory suggests that the Inca had knowledge of chemical or thermal treatments that could temporarily make stone more plastic, allowing it to be shaped or molded, after which it would re-harden to its normal state. Proponents point to local legends about plant extracts that could soften rock and to the undeniable fact that no other explanation fully accounts for the precision. The problem with this theory is that there is no physical evidence. The 2024 research team's scanning would have detected any unusual chemical signatures on the stone surfaces if such treatments had been used. They found nothing. Which brings us back to the central mystery. If the stones were not softened, if they were carved through purely mechanical means, how was the precision achieved? The 2024 findings tell us that the polygonal shapes provide earthquake resistance. They do not tell us how those shapes were created. They document the engineering principles that make the walls work. They do not explain the engineering process that built them. Here is something else that does not add up: the scale of the operation. We are not talking about a single wall or even a single building. The polygonal masonry technique appears throughout Cusco and across dozens of sites in the Sacred Valley. Conservative estimates suggest tens of thousands of precisely fitted polygonal stones, possibly hundreds of thousands if you count all the sites attributed to Pachacuti's reign. Even with the most optimistic assumptions about the number of workers and their efficiency, creating this volume of precise stonework in 30 years seems impossible. Many of these structures may have been inherited from earlier builders, maintained and modified by the Inca, who added their own work around and atop foundations they did not originally construct. This would explain the variation in quality. It would explain the Inca's own stories about inheriting great works. It would explain why the best stonework appears to be the oldest, buried deepest in the walls. It would also explain why radiocarbon dates cluster around the 15th century, because those dates are dating Inca modifications and additions, not the original construction. But if this is true, who were the original builders, and when did they actually build these walls? We do not know. There is no writing system, no contemporary documentation, and no clear way to date the stones themselves. What we have are structures that, by our current understanding, should not exist given Bronze Age capabilities. We have Spanish chronicles reporting Inca claims of inheriting earlier works, and physical evidence showing construction quality degrading over time rather than improving. The mainstream narrative asks us to believe that the Inca, in the span of a single lifetime, developed stoneworking techniques sophisticated enough to create walls that have never been equaled, combined them with seismic engineering principles that would not be formally understood for another 500 years, and did all of this with tools that physics suggests were not adequate for the task. That story also requires that no evidence of development or practice was left behind, and then, for reasons unknown, the knowledge was lost immediately, with later Inca work showing dramatically reduced quality. The alternative narrative is that the most sophisticated stonework is older than commonly attributed. It was built by peoples we do not have clear records of, and inherited and modified by the Inca, who tried to maintain and add to what they found. This account aligns better with the physical evidence, the patterns of construction quality, and the Inca's own historical accounts. But it forces us to push the timeline of sophisticated engineering capabilities earlier, and to admit there are chapters of South American history we simply do not understand yet. The stones themselves do not care which narrative we prefer. They sit in those walls in Cusco, fitted with impossible precision, bearing the marks of techniques we cannot explain, and showing evidence of both ancient sophistication and later decline. They survived earthquakes that leveled Spanish cathedrals. They outlasted the empire that claimed to build them. Despite our most advanced scanning technology, our computer models, and exhaustive research, we still cannot fully explain how these walls were made. The 2024 findings reveal the hidden engineering of the wall's earthquake resistance. They do not reveal the hidden engineering of the wall's construction. That mystery remains unsolved. The precision is real. The scale is documented. The survival is undeniable. The explanation is still missing. Something is deeply wrong with the history we have been told about these walls, not because of conspiracy or cover-up, but because the physical evidence does not align with the capabilities we attribute to the builders. The more precisely we measure these stones, the more impossible they become. And that impossibility sits there in plain sight, in the heart of Cusco, waiting for an explanation that actually accounts for what exists. What do you think? Are we looking at the masterwork of Inca engineers who somehow achieved precision beyond their supposed capabilities? Or are we looking at inherited stonework from earlier peoples whose techniques were lost to time? This is not myth or speculation. These are real walls, real stones, real precision, documented with laser scanning and measured to fractions of millimeters. And despite everything we have learned, we still do not know how they were made.